simple map honorables, jury members and teachers. Today's our topic is application of trigonometry in real life. Trigonometry is useful in our day-to-day life. It is the branch of mathematics that deals with the relationship of sides and angles in triangle. It is helpful in finding the height of mountains, buildings and roads. Also, it is used in astrology to find the distance between planets and stars. It is also used in GPS navigation systems, physics and architecture. Starting with the word trigonometry, trigno means triangle and metry means to measure. It is the measurement of everything possible in triangle. But for trigonometry to exist, it is important for the triangle to be a right angle triangle. Detailing the triangle, the desired angle is called theta, and the side opposite to the right angle is known as hypotenuse, and it's the fixed one. The challenging thing is to distinguish between the base and the perpendicular. Base is the side adjacent to theta, and perpendicular is the side opposite to theta.
Now, I want to introduce you with some functions of trigonometry. There are three main functions of trigonometry. They are sine, cosine, and tangent. Trigonometry has three other functions too. They are cosecant, secant, and cotangent. Moving on to the model, our very first concept is clinometer. Clinometer is derived from two words, clino and meter, where clino means slope or incline. So basically, clinometer is an instrument used for measuring angles of elevation, slope, or depression respectively. As you can see, we have the angle of elevation of the top of the building is 45 degrees, and the angle of elevation of the tree is 30 degrees, and that of a pole is 60 degrees. When we are given the desired angle, that is theta, and any one of the three dimensions, we can easily find out other two dimensions with the help of tangent function of trigonometry. As in this case, height of the pole is given to be 4 cm and the angle of elevation is 60 degrees. In order to find out the distance between clinometer and the pole, we use the tan function that is perpendicular upon this. Next, we are given the distance between the clinometer and the tree. In order to find out the height, we use the angle of elevation in tan function that is perpendicular upon this. In another, we are given the height of building and the angle of elevation that is 45 degrees. In order to find out the distance between the both, we use the tan function that is perpendicular upon this.
And this working model illustrates the value of the angles at a specific trigonometric ratios. By rotating the above circular cardboard, we can find the value of every trigonometric function for a certain angle. For example, the value of sine theta at 30 degree is 1 by 2. Value of tan theta upon 30 degree is 1 upon under 3 and so on.
As we are dealing with the concept of right triangles, so another concept relating to them is Pythagoras theorem. Pythagoras theorem is a fundamental relation in Euclid's geometry between the three sides of a right angle triangle. In this working model, the biggest square represents the three square represents the different sides of the triangle. The biggest square represents the hypotenuse of the triangle, and the other two squares represent the other sides of the triangle. When the grains in the biggest square, when rotated, covers the other two squares. It states that the square of the biggest square, that is hypotenuse square, is equal to the sum of the squares of the other two squares, that is p square and b square. Hence, h square is equal to p square plus p square. All thanks to the Pythagorean who gave us this such an valuable result, which we can use in solving various problems. Here we have illustrated and another useful example. As we can observe, a boy standing on the top of the building, the angle of depression from his eyes to the top and bottom of the building is 30 degree and 45 degree respectively. Here we are given the height of the building AB. We can find the height of another building and distance between both of them by using the tangent function of trigonometry.
Now, moving on to an interesting example of trigonometry, that is breaking tree due to storm. Here, suppose a tree was standing erect and it had fallen down due to any natural calamity such as storm, and it touches the ground at a certain angle. Now we have to find the total height of the tree. It may not seem appealing to us, but trigonometry has made this concept very easy. To find the total height of the tree, first of all, we will find the perpendicular distance. The angle of elevation is given to us 30 and the base distance is given by applying the tan function and using a very famous trick, that is Pandit Badri Prasad Har Har Bole Sona Chandi Tole. We can find the ratio of tan, that is perpendicular upon base, and find the perpendicular. Then we will use the sine function and its ratio is perpendicular upon hypotenuse. Using the same trick, we will find the hypotenuse. Adding the perpendicular and hypotenuse will result in the total height of the tree.
Wrapping up, we would like to conclude that trigonometry is a very different subject than most of the maths that we encountered in our lives previously. It is a quite interesting subject and it takes a different way of thinking to understand. Without trigonometry, our life would be much more difficult. All thanks. It is a great invention, and thanks to this, many architects need not to go through the trouble to calculate things. At last, we would like to thank Career Academy for giving us the opportunity.
And a great thanks for you to showing your interest and attention.